Okay, so we are doing the problem number 17. 17.
Yeah.
17. So what is given in this question number 17? When a radiation of wavelength lambda, radiation
Yeah.
means you should always get into your brain that it is some
E is
light.
equal to H2.
Yes. Is incident on a photosensitive metal. Okay.
Hmm.
Wavelength, that is why I took it as yellow color. Okay, of lambda is incident on a metallic surface. This is the metallic surface. Okay,
Okay.
metallic surface. This is the metal.
Vs is equal to 4.8 volt.
Yes, very good. Stopping potential they are given to us. Vs,
We can
capital
write it
Vs.
as 4.8 by
Yes,
1.6 into 10 power minus 19
yes.
volt.
Vs they are given. Capital Vs, which is stopping potential is how much?
4.8
4.8
volt.
volt they are given. If you
Yeah,
want
they
to
gave it
convert
in
that into
volt.
energy, if you want to convert that into energy,
4.8 into
EVS.
1.6
Yeah,
into
1.6.
1.
So this only, no need to say that 1.6. You just have to write EVA, EV. That's all. This will
Okay.
be this. What will this be? Stopping energy. This will become the stopping energy or kinetic energy. Simply,
Yeah.
this is the maximum kinetic energy. Understood?
Okay.
This is nothing but half mv max square. Is it clear? Okay.
Yes.
If the same surface is now, this is the situation number one. Now, second situation is the same surface is illuminated by some other color light. The same surface was incident by some other color. What is the some other color? We do not know. Of radiation, double the wavelength. So this was your lambda 1. Now your lambda 2 is how much? 2 times lambda 1 is irradiated by double the wavelength of. Then what happens? Then the stopping potential. This is Vs1. Now what we have is Vs2. What we have is it visible? What we have now is Vs2. Vs2, stopping potential in the second situation is 1.6 volt. So what is the kinetic energy corresponding to this? Can you tell me? EVS2, that's all, no? Yes or no? Earlier it was VS1.
Okay, but
Huh? So this is
just a
EVS1.
second.
Now this is EVS2. Is how much? Tell me. 1.6
Wait.
electron volts. That's all.
Okay. This is
Okay.
VS1 and VS2 is equal to 1.6.
Yes.
Okay, with double the wavelength.
Double the wavelength. This is the double wavelength, and this is the stopping potential. So the corresponding kinetic energy. This is what is this? What is this value? This is kinetic energy. Can I write that as K1 means kinetic energy 1. What is this? Simply K2. Okay, understood.
Okay.
Then the threshold wavelength for the surface is how much? What is threshold wavelength? Lambda naught. We want to find out the lambda naught. Is it understood till here?
Hc by lambda is equal to Hc lambda naught plus
Already we
kinetic
did the
energy.
same numerical. We did the same numerical earlier. Which numerical? Just now we did the same numerical. This and that is the same. Anyway,
Divide 1 by 2.
so how to do? Which formula we have to use?
Divide equation 1 by equation
But
2.
in this situation we cannot divide. In this situation, division is not possible. Why? Earlier lambda.
Then subtract.
Here we have to subtract. Very good. Subtraction we have to use. Why? Why not division? Because that time the frequencies were product of threshold frequency, right? That is why we used to subtract, divide and did the equation. It was very easy. Now we cannot divide it. We have to subtract. Understood? Okay, let's write the equations. First equation, second equation. What is the first equation? H C by lambda 1. This is the first equation. Is equals to H mu naught plus this is the kinetic energy 1, right? I'm writing that equation as an equation.
Yeah, plus kinetic energy 1.
Is it the first equation? What is second equation? Hc by lambda 2 is equal to Okay.
Sir, you can write it as HC by 2 lambda 1.
Yes, yes, of course, I will write that only. I will write step by step, I'm writing. Okay. Plus
Okay.
K2. Now subtract equations. Whichever you like. This will get cancelled anyways. Okay. And now substitute these values. If you substitute, yeah, what you are saying is correct. HC by, first you write lambda 1. Second you write, if you subtract this one, what is the second equation? Just now you told
Sir,
me.
can
No?
you cancel HC and HC?
No, 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 no. How can you do that? I told you, you have to take LCM. You have to take LCM.
Why can't you
HC,
cancel HC and HC though? They have the same values.
they are in the numerator. Denominator is the not the same, right?
But when you send it that side, it will become lambda 2 by lambda 1.
This
2
lambda 2
lambda
became
1
2
by.
lambda 1.
Yeah, but you can cancel HC and if you send it up, it will be HC by lambda 1 into 2 lambda 1 by HC, right?
We have to take LCM, no? HC, we have to take as common. HC is common, right? So can
Yeah,
I rub
okay.
this part?
Yeah, you can. Wait.
Right.
Yeah, you can rub it.
Okay. So we are doing the subtraction, not division. Remember that.
So you're doing HC by lambda 1 minus HC by lambda 2. I
HC
mean,
by lambda 1
1.
minus HC by lambda 2. That's what we are doing. Is that clear? And
Okay.
VS1 and VS2 have been converted into K1 and K2. Okay. 4.8 and 1.6. Remember those values. We're going to substitute it now. Okay. Then what we're going to do here? HC by lambda 1 minus HC by lambda 2, which you already told me. HC by 2 lambda
You
1.
can take the, sir, you can take the LCM as 2 lambda 1.
Yes, correct. That's true. Correct. Very good.
So it will be 2HC minus HC by 2 lambda 1. You'll get HC by 2 lambda 1.
Vishal, put on paper, Vishal. Don't put in air. That's what mistakes will come when you try to think them. When you put them on paper, things will be totally different. Okay. What is K1? 4.8. What is K2? 1.6. Now take HC common. By lambda 1 also common. Now to take the LCM. What is the LCM? 1 minus 1 by 2.
The answer. Oh my God.
1 minus 1 by 2. Is it or not?
Yeah.
1 times is 1 by 2 times.
I just told you that the answer was 1 by 2.
Yeah.
It was HC by lambda 1.
So better write it. What is 4.8 minus 1.6? 3.2.
3.2.
Okay. Now what do we need? We need HC by lambda. Okay.
Yeah.
Okay. We know the value of HC and everything. We have to substitute. That's all. Is it understood? What we have found out is HC by lambda 1. What we have to find out is lambda naught. How do you find lambda naught? Substitute this value in the equation 1 or 2. Any equation you can substitute. This is equation number 3, right? Okay.
Yeah.
Substitute this in either of the value to find out the lambda naught. Because we have to find out the threshold wavelength. What does the threshold wavelength of the surface is they are asking. Till here you written?
Yeah.
Now first go back to the equation number 1. What was the first equation? First or second equation? Any one equation you need. Wherever there is HC by lambda 1, you have to substitute 6.4 instead of that. Okay. So what was our first equation? HC by lambda 1.
Value? Sir, what is K1's value?
K1 value they gave no in the question 4.8.
What 1.8?
4.8 first K1 value. First they gave in the data. HC by lambda 1.
So the answer is, sir, the answer is 2.6. The answer is 2.6.
Have you solved it?
Yeah, it's 2.6. The answer is 2 lambda.
Yeah, we have to find that. No, hc by lambda 1 is equal to that side. What is there? Hc by lambda naught is there. Plus K1. What is K1? 4.8. Luckily, we know this value.
4.8.
Hc by lambda 1 we know 6.4.
Yeah,
Is it or not? Is equal to hc
yeah.
by lambda naught plus 4.8. So divide, subtract.
Wait, what are you doing? I thought, sir, equation 1 is hc by lambda 1 is equal to h nu naught plus k1.
What is h nu naught? Hc by lambda naught, no? What is
Yeah.
h nu naught? H C by lambda naught. Is it or not?
Yeah.
That's what I wrote. That was h nu naught, right? H
Yeah.
nu naught becomes hc by lambda naught, no?
Yeah.
Understood, Vishal?
Oh.
Okay. Is it clear? So, what we got to do is, what is 6.4 minus 4.8? 3 point.
Sir, hc by lambda is equal to, sir, hc by lambda is equal to 2.6.
hc by lambda not use that word.
Yeah, 2.6.
2.6 we got. But we don't need 2.
Yeah.
This thing. What we got is hc by lambda naught. What we want is the threshold wavelength of the surface is how many times lambda 1. Understood? Now this is my equation number 4, is it or not?
Yeah.
And this is my equation number 3. Now I have to compare this lambda naught with. Did you subtract this properly?
Yeah, it's 2.6. You can check for yourself.
Check it once. Not. Subtraction.
Yeah, 1.6. 1.6. My bad, I made a mistake.
6.4 minus 4.8 is how much? 1.6. Right? So it is 1.6.
Yeah.
This is my equation number 4. Now what? I have to relate this lambda naught with lambda 1. That is my aim. Understood? So how do I relate them?
Yeah.
Again, relation, whenever you ask relation, what you have to do is divide. That's it. Always. When I want to find out a relation, it means I have to divide those equations. That is how I'm going to get the relation. So hc by lambda naught. This is my first equation divided by this equation. What is this equation? hc by lambda 1. Which is your lambda? That side what will come? 1.6 divided by 6.4. Ones are, fours are. hc cancel. What are you going left with? Tell me. Lambda, this will become reciprocal, right? That day you asked me about reciprocals. Lambda 1 by, this will go up.
Yeah, okay. Lambda 1 by lambda naught 2.
Ah, very good. Lambda
by
1
lambda
will go up here. Lambda 1 by lambda naught is equal to how much? 4. 1 by 4, not 4. 1 by 4, is it or not?
Yes,
what do I need? Lambda 1 I want or lambda naught I want? What is lambda naught this side is equal to 4 lambda 1, which they gave us lambda.
4.
Understood? Lambda 1 they gave us lambda. Understood? So what I got final answer, lambda naught is equal to 4 lambda. The B option. Understood?
Okay, got it. Let me just do this.
Is it clear? Understood each and every step. Relation, when they say relate those parameters, we have to divide. Is it understood clearly? You can note it.